Hello everybody and welcome to a technical webinar about Scia Engineer applied to concrete buildings. My name is Chef Baines. I'm a product service engineer in our headquarters in Belgium. I will be giving you this presentation / webinar about Scia Engineer. First I would like to welcome you all and explain a bit why we give this webinar. First of all, this webinar is not just meant for new customers or new users, but also for our existing users to give some additional information about the webinar. This webinar will be about creating a model made in concrete to calculate concrete elements such as beams, columns, plates and walls. And we will conclude this with a summary about things that I have explained, and I will also give you our contact details. So I will commence in Scia Engineer by starting a new project. So I will start a new project of the type analysis. This is the type which you can calculate. And in this new project, I will first have to start with the project data. So in general, you have to choose which type you're calculating, 2D, 3D, and which code you're using. So for the code you're using, you see the default I use now is Eurocodes, but I can also add new codes like the British Standards or the American code or the Brazilian code, or we have also other codes which you can see here. If I would want to add one, I would have to choose the code. Then it gets loaded into the project, and then I have the possibility to choose it here in the list. If you are applying the Eurocode, then you can also choose a national annex. So I will now use the Eurocode, and I also have to indicate the materials which I'm using and the default materials. So let's say C2530 and B500A, for example. And in my functionalities, I can indicate other things which I want to use, other functionalities which I want to activate in the project. So, for example, a subsoil. I want to use a subsoil. Next, if I tick OK, then it will start the model, start the project. It will initiate it. And the next steps will be actually following the main menu from the top to down, or actually just to the engineering report, in which we will report all our results. So project is the part which I have just configured. Next I have line grid and stories. So it's possible to use a 2D line grid or a 3D line grid. But in fact, if you use a 3D line grid, you can also use a 3D line grid as a 2D line grid. For example, if I type here, let's say a distance of 6 meters, repeated 5 times, I can do the same in the y direction, 6 meters 5 times. And if I don't indicate z, the vertical direction, then in fact I have a 2D line grid. And if I tick OK, then I can apply it, or I can use the command line and put it in the origin, which is 0. In fact, it's 0, 0, 0, but it's the same thing. And then you see that it gets placed in the origin. So thus I have a line grid. And now I will continue. I will close my line grid menu, so I can continue this list. The BIM toolbox is something we use if you import a drawing in Scia Engineer, for example, an EFC or DWG, and you want to convert it into an analytical model. So I will directly go to structure and I will start inserting elements to calculate. For example, you can see here under 1D member you have the possibility to input members, beams, columns, or 2D member you have plates, walls, or shells, which are curved 2D elements. Let's say I want to input a plate, then I have to make sure that my mouse goes to the correct options. I do this with the snap mode. I can configure it with the snap mode, and I definitely want to use the line grid. Because if the line grid is activated and I want to input a plate, and we'll see, let's say the correct material would be concrete. See, let's take a thickness of 300 for example. And now you will see that the mouse tries to jump to those red points, the points of the line grid. So for example, I can input lines here and you will see the figure which I'm going to get. And I'm also going to input a curved edge. Here you can see which curved edge I can use. And I'm going to use a new circular arc. And in fact, you just have to follow the command line. So it says you're busy with a new 2D member, creating a new polygon. And now you're busy with the circular arc and he wants an intermediate point. So for example, this point, and then the end point, you see that the end point will make the circular arc. For example, this part. And then I'll just create the rest of the plate with straight lines. And then you have something like this, for example. This will be my foundation plate. And let's say I want to add, for example, walls. Well, let's say that the walls are 200, for example, and 3 meters high. In fact, the wall, you have to create a wall by drawing a line. And it will create a wall that is 3 meters high. But might be more easy to just use the last option, select line, and then I can select lines and it will put my wall on all the lines selected. Then you can see now I have walls around my plate. You can see now I have something like this. Let's say I also want to have inner walls, so I choose wall again and still 200, okay, 3 meters, okay. I'm gonna just put it here by using lines. And now I have inner foundation walls. And let's say for my other parts that I'm using columns, then I can just double click columns, but it will need a cross section for the column, so that's why it directly puts me into the cross section menu. So let's say a circular one. And my column will be, let's say, I want this property to be 350 millimeters. There you go, okay. Next I say close, and then I say close again. It should be 3 meters high, okay, it already knows it. And then I'm gonna put some columns in my in the points that appear. Now let's see, I think I clicked a bit too soon there. So I have one column too much, and I'm just gonna delete it. There you go. So now in the bigger spans, I have added columns to support the next floor. To copy my first plate, my foundation plate, because the plate on the next floor is gonna be a bit similar, I'm gonna use the copy option. So under modify, I also have copy. And I'm gonna apply a vector, and then it's gonna use that translation to copy my foundation plate. See, I have copied the plate, and now, well, it's closed. Let's say I also want to use an opening. For example, here I have 2D member components, opening. It says command line, new opening, please select any slab as master. For example, this S13, and then I'm gonna input the opening with these properties. So an opening can also be a panel. For example, if you have a roof window, then it's not gonna apply any stiffness to the structure, but it can take loads, because you normally pick a glass that won't break if it snows on it, for example. So now I have added an opening here, and now the opening is here in the plate. Let's say I want to modify this plate. For example, my foundation plate was 300 thick, but the next floor doesn't need such a thick plate. So I can select my, that's not S3, it's S13 that I need. And I can just modify the properties on the right. Let's say it's 200 thick. But I have local, in local places I have made it more thick because of the columns which are attached to this plate. And if I want to apply a different local property, for example, different local thickness or different local material, then I'm going to use a subregion. These subregions are applied on a plate. Now, to be able to use my coordinates for it, I have to move my axis. So let's say I move my axis to this node, for example. It's 1, minus 1. Oh, my bad. It says subregion select master slab. So in fact I could say S13 because it's S13. And next it's going to give the subregion, let's say a thickness of 300, and the material should be concrete 2530. And now I can input the polygon. It's going to be a rectangle, let's say from -1, -1 to 1, 1. So now I'm applying it around my axis, which I have just moved. And now I have a local region with different properties. As you can see, it's thicker. The extra thickness is divided over the two parts of the plate, the upper part and the lower part. Now, I can also do something else. I can say that I want it to be parallel. And if I choose top, I want it to be parallel with the plate at the top side, then the additional thickness has gone to the bottom side. Or differently, if I choose bottom to equalize, then you will see that the extra thickness comes at the top side. So let's say top again. So the top side is parallel, it's one plane now. Well, we also have other columns, as you can see. So what I'm going to do now is I want to place the same subregion at the heads of the other columns. So I'm going to use modify, copy. It says start point. For example, I take here the central point, and then I can just copy it to there, 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 and there. Now I've copied the subregion to the other columns. So the total model which I have now is, there are in fact two plates supported by walls and some columns. Let's say my entire building was built with the same elements, the same composition. I would be able to say modify, multicopy, and let's say we copied, for example, 9 times, so it's a 10-story floor, 10-story building. And it's each times 3 meters vertical between two copies. This, how to define the distance between two copies. Well, then I would have this big building of 10 stories. Now to make things, to make it more easy, I'm just going to copy it one time. So let's say I want to keep everything. You can also select it like this, say delete. There you go. Now I have 2 stories, for example. And let's say that the our client, for which we are calculating this building, wants his first floor to be more open. So I'm gonna delete some of the long walls and replace them by some separate columns. So I've removed these walls, and now to ensure stability, I'm gonna add some columns. Here you have column. There you go, I have my column again. It should be 3 meters. Okay. Now to add them, you see the red points, those are the points which I can pick onto. I'm going to use my snap mode and say I want, for example, I'm going to use option H. I want my lines to be divided in, for example, 4 parts, so that I can choose here point in 1/4 of the length, and then here we have a node because it's the middle of the circular arc, and 3/4. And then, for example, the shorter walls, where the shorter walls were, I'm going to choose, for example, in 3 parts. So I can say, where is it? Here. Which is that. Just have to go over the edge until I find the right point. Okay, and that's the other point. And I also have the other edge, 2/3, 1/3. There you go. And now to show the volume again, you can see I have separated the 2 plates with just a couple of walls, and the rest are columns. Now that's my model, and to finish up the model, so I have added the elements. I also have to add supports, which I can find under model data. For example, we have surface supports. There I can choose from the system database different materials. Let's say sand, clean, moderate, for example. And I say copy to project. If I pick copy to project, you will see when I close it that that material is copied as a subsoil in my project. And these stiffnesses for ground are now indicated for that material, for that subsoil. In comparison with sub 1, there you would have to insert them yourself. And in practice we take something about 10% for the horizontal rigidities or the horizontal stiffnesses. There you go. And then I'm going to apply my subsoil to the bottom plate, S1 in my case. And you can see the support indicated with the little triangles. Those triangles. So now I have a support for my model. So now it won't be unstable anymore. Now to complete your model, you will always have to do connect members nodes. And what will it do? Well, this connect members nodes, it will make sure that everything is connected. Because the finite element method says that you have different nodes, and then those nodes are connected by plates and beams and columns, etc. So if you use those steps, then the program won't know when there's a point coming to the middle of another beam, for example. And this little option searches for those intersections. It searches that himself. So let's say I want to say proceed with all entities, yes. And what it's going to do if 2 things, for example this node and that beam, are close enough together, so close enough is indicated with tolerance, then it's going to connect those elements. So let's just say OK, and we'll see it has made 41 intersections. And those intersections, they are indicated with the red lines that you see here. And the red line will indicate that, for example, now this line connects members S23 and S25. And 23, that's this wall, and 25, that's this is 23, that's 25, for example. So all things that might not have been connected properly are now properly connected. Also, if I don't modify this wall, let's say I change the height to 10, then you will be able to see that this intersection line has followed in a bit weird way. But if I were to use these options again, then it will correct the line. So now the line is correct again. And if I'm going to put the node back, so now it has made this line with a node at the end. If I'm going to correct it again and use those options, then it will refresh all the connections. It will say I've refreshed or updated 41 intersections. And the check connects duplicate nodes because those were the nodes we had here. So in fact, from different operations there can become things that might not be connected correctly or duplicate, but then the program will detect that himself and correct the problems. And then it will be solved. Now to continue, we have our model here. This is our house up till now. Now we're going to input loads. So if we want to input loads, then we have to go back to the main menu. Here you can see main menu. So I have to click close at the bottom in the structure menu. And I'm going to continue to load. Now in fact, all my loads, if I click twice on loads, I should be going into the load menu. But all loads should be classified in load cases. But there are no load cases yet because, well, we haven't made them. So to solve that, the program will indicate for himself that you should make load cases. And that's what it's doing now. LC1, that's my first load case. And for the first load case, it usually indicates the load type self-weight. And the type self-weight will create loads itself automatically. It will calculate the weight of the elements which you have indicated, because you know the size of those elements, you know the cross sections, which surface area that has, you know the materials. So in fact, the weight of the elements which you have inputted can also be calculated by the program. So let's say load case 1, that it remains self-weight. And I'm going to create a second load case with my permanent loads. And my permanent loads will be loads additional to that self-weight. And next I will make a variable load case, or load case with my variable loads. And to indicate this, I have to change my action type to variable. Now, in this demonstration or webinar, I'm just going to use static load cases, and I'm going to use a static calculation, but it is also perfectly possible to indicate dynamic loads. For example, dynamic loads created by seismicity. So you have ground acceleration spectra, or ground accelerations, which you're going to apply to the structure. And those ground accelerations are going to create forces, and you can calculate them in Scia Engineer with dynamic load cases. Or an harmonic load case, so for example a machine that's vibrating, or just general dynamic loads, so a load that is variable in time, that changes in time. Those kind of different loads are loads that you can input here. Well, let's say, for example, for my permanent loads, you can see there are point forces, line forces, surface loads. We also have terminal loads, moments which you can apply, or displacements. Now I'm going to apply a surface load onto the member. So let's say that each plate has an additional surface load of, for example, 2 kilonewton per square meter. I'm going to say this plate, it should be the 13 one and the S1. There you go. Then you confirm with escape. Escape again. It's a bit big. You can make it smaller. There you go. And now I have added these loads. So I've also added one here. For example, those are my additional permanent loads. Now I can also input other loads, let's say I have for my serviceability or my variable loads, let's say I have local loads. I'm going to use free loads, free surface loads. For example, of, let's say, 3, for example. And I'm going to apply it on the middle plate. And let's say it runs over here. So I'm using the indicated dots now to model it. Modeling it in that plane. And next I'm going to say that the selection is select, and I'm going to update its selection and say that it has to stay on the middle plate. There we go. Then I have inputted my load cases, and next I will have to combine those load cases. So here all the loads are combined. You can see I have my variable loads. For example, I have my permanent loads, and I have my self-weight, which you cannot input because it calculates it automatically. And for the next step, I'm going to use combinations. So I'm going to exit the load menu, and I'm going to go to load cases and combinations. Now, load cases are again the load cases which I have just created. You can access them again. And the next step I'm going to do is create combinations. There are different types of combinations which you can make: envelopes, linear combinations, or Eurocodes combinations indicated by the EN. Let's say we want an ultimate limit state combination from the Eurocode. So Eurocode ULS. And I'm going to add all load cases in it. There we go. The next step is maybe also a serviceability limit state or service limit state. There you go. And I'm going to use SLS. It's a quasi-permanent combination because that's a combination I can use to calculate my cracks. There you go. Now I also have result classes. And what's the result class? That gives the envelope of everything that is inside. So for example, if you would ask the moment of a class, then it would look at the different components that are inside and give you the biggest moment or the smallest moment, depends on what you're asking, in each distance in, for example, a plate or a beam or a column. So let's add those two and then tick OK. So I've created a class which is the envelope of those two limit state combinations. The next part is just actually continuing in the main menu. The next part is the calculation and mesh. So let's go to the calculation immediately. And there you have the linear calculation. So I'm going to perform the linear calculation. And what it shows now is the maximal displacement, translation, and the sum of load and reactions. That's just something you always have to stay, you always have to criticize programs, always have to check if they are doing it correctly, and it's something that we do too. This is the check that we do too, to control or to check if everything went okay. And this check just looks for each load case at the sum of the loads, and it compares the sum of the loads with the sum of the reaction forces. And if it's okay, then it will say here that the sum of loads and reactions is okay. Now if you have performed the calculation, then you will see the results menu or results in the main menu. And if I open results, then you will see it becomes possible to ask for displacement of nodes. So the nodes, those are the red dots, or to look at the deformed structure. So for example, if I want to look at the deformed structure for the self-weight, you can see how the structure deforms under the self-weight. Or I can look at the forces, let's say for example, the internal forces in beams. For example, for my ultimate limit state combination, I'm going to look at my normal forces. And then you will be able to see the normal forces in the structure. And with extreme, you can ask for the number of values. So if I choose the value for each member, it will indicate me what the normal forces are in each element. Now you will see here a certain value, 800, but I can modify the setup a bit. Now I'm not going into detail, I'm just going to activate the units. Because if I refresh, then you can see it's in kilonewton. If you would want to change those units, then you have to do it under setup and then units. Now the other things which I can ask for are the results in 2D elements. For example, my internal forces in my plate. Let's say I want to look at, for my combination, my ultimate limit state combination, I want to look at my internal forces. It says here for all plates. So now you will be able to see the forces in the plates, also the walls. It has calculated everything. For my ultimate limit state combination, and these are my minimal envelopes. If I ask for my maximal, then you will see that the value becomes bigger at the bottom. Now it's also possible to look at the contact stresses. Those contact stresses are the stresses given by the soil. So for example, well, now the value is rounded up, so I'm going to use the option which I mentioned. I'm going to go to units, and I want to see for my results that the stress is not with 1 decimal but 5, for example, so that I can see more in detail how the stresses given by the subsoil are divided over the plate. And you also have, for example, my displacement of nodes. Let's say I have displacements of nodes for combination ULS, and I'm going to take the top plate. I've selected by using the border, and now I can see the vertical displacement in the top plate. Now the results in Scia Engineer will always be linked to the entire model. So for example, you can see here that the deformation is between 2.8 and 10.9. If I would remove a column, let's say this one, delete options, delete everything, OK. Oh, I have deleted a plate too much. I'm going to choose the undo option and just delete. OK, I'm just going to delete the column. Now I have to calculate again if I change the model. What I want to show now is if I remove one column, you will see that the results will completely change. Because the displacement becomes much bigger in the part where the column has been removed. And from 10.9 it has changed to 32 because the column has been removed. Now I'm going to use the undo option until the point that the column has returned. So, you can see it has returned. I have to calculate again, of course. So, you can see results in plates like that. I'm also going to use a section. Why a section? Because there are times that you want to look at results in just a separate part of your element or your construction. So let's say I have put a section over here. So a cut actually, a cut. And I'm gonna look again at my displacements of nodes, but now I'm gonna indicate that I want to use my section. And if I look at my section, then you will see how the displacement, how it happens over that line. And by changing stream to no, for example, I can look at it at more points. And with the drawing setup, I can activate, for example, the units. And then for all the results, there is always a preview, which you can see in the property menu at the bottom. A preview. And that preview will give a table which explains these results. Now here you have a lot of options. But these are all the displacements which can occur on these elements. Those are linked to your property of extreme. So let's say we want this figure later on in our engineering report. Then you say live picture into engineering report. Insert and close. And if I want this table in the engineering report, I'm also going to click with the right mouse button and I'm going to say table to engineering report. Also going to say insert and close. And that's how I send it to the engineering report, just like that. Now I'm going to go further and look at my concrete results. Because in the concrete menu I can also do different kinds of things. For my 1D member, I can input individual data, that's member data, and then look at, for example, you have internal forces or theoretical reinforcement. It's indicated under member design. Now let's say for combination ultimate limit state, I'm going to look at the total amount of reinforcement which is required. So that is what it's calculating now. The amount of reinforcement required in each section. And each section is indicated by, well, in the case of columns, by a horizontal line. And you can see at the bottom that it's busy for, well, maybe I'm using a bit too much. Let's just cancel it for now. Okay, it was done. The result which you get here indicates how much reinforcement is needed. The W message, 270, that gives a warning. So in fact, our warnings are mostly informative. You have to look in the calculation info. So actually in the property window we have to ask all information. If you choose refresh, you can see all information here in the window. This result to 1257, well, if I change my drawing setup a bit, I can ask for the units and it will indicate that you need that amount of reinforcement, and the preview explains this value more in detail, and it will say, well, you have these moments for a circular column, and well, it's found by applying 4 bars of diameter 20 into that column. So refresh gives you the diagram, calculation info gives you more information about the different warnings. Now the errors are something you have to look in detail. It says no selected cuts were found, and this is because here section is all, and it will also look for selected cuts. Selected cuts are cuts which you have indicated yourself. Because what the program has done, at each line it has calculated the values. But you can also input positions yourself and it will make sure that it has calculated that precise position. Now, for example, let's add a beam. So I'm going to take the bottom part. I'm going to take this plate, for example. I'm going to take these columns. this column. Okay. Now if I just keep that part, oh, I have a couple too many, I'm going to remove them. Well, now I'm not removing them, I'm making them invisible. As you can see, here is everything. This is the part which I want to keep. So that way I can look more easily into some detailed results. So let's just look in detail to our columns. And I was going to add a beam. So in the structure menu, I'm going to add a beam. It's here, beam. Let's say the distance between those two things is 6 meters. My direction is not correct, it should be the Y direction. In the midpoint. There you go. Now I've added a beam over there. To connect everything, I have to choose connect members and nodes again. There you go, because two nodes will be linked, and those two nodes are actually these nodes. Okay, and I'm also going to add a load case. Let's say load, and for, let's say, permanent load, I'm going to put, which kind of load I'm going to use? Let's say 30 kilonewtons per meter on it. Okay, now I'm going to go back to the concrete menu. And you will see that you have less options. That is because the project is no longer calculated. If you change your model, then it has to delete the results. Because otherwise it's not compatible anymore, your model and your results. Okay, and now we're going to look again at the member, so the amount of reinforcement just for these couple of elements. So I'm going to choose selection current. Now if we look in detail, you will see that it gives a bit more reinforcement where the column is connected. See, okay, and have I done something wrong? Because it says that the combination has no moment. Okay, so I'm gonna check that again. This line 4 is in the Z direction. It's in load case 2. It's completely on it. If I look again in my load cases and combinations, that I can see that load case 2 is included. Okay, then I have to do the linear calculation. Go, and then I'm going to look at my concrete menu and ask for my member design. Okay. So the reinforcement which I get here, I'm just going to remove some temporary data. The reinforcement which I get here is calculated with my ultimate limit state combination. It's not in the current combination anymore. There you go. I haven't made a new cross section. That was a part I didn't understand. I have to create a new cross section, and I am gonna choose a rectangular one because otherwise it won't go correctly. There you go. Now the amount of reinforcement which I get here is calculated differently for the beams and the columns. As you are able to see, for my beam, it will calculate upper and lower reinforcements, while for the column it calculates main reinforcement. And that is because for the column it has to look at the how the forces are designed. And well, it's gonna be a bit different, because if I look at the internal forces in the concrete menu, there it shows me how my moments are recalculated due to concrete rules. And for columns, for example, it will take into account the different eccentricities. So as you can see here, for columns, I've modified this table a bit. I will put it back to the default, but it's something because I want to look more at more information, more in detail. For columns, it has taken the eccentricities, the different eccentricities, to find second order moments, for example. So it has augmented the moments due to eccentricities, possible imperfections, and possible additional moments due to the slenderness. So that is already taken into account. And for the next part, my member design, it will indicate how much reinforcement you need. And the amount of reinforcement you need is indicated here. So the 526 that you can see here, it means that you will need at least 2 bars of diameter 20, because that's 628, to have more than those 526. And for your column reinforcement, you will need 5 or 6 bars of diameter 20. And it is also possible to input that reinforcement yourself. That takes some time, so we're going to do it automatically. We have automatic member reinforcement design, and there I can choose reinforcement design. Let's do it based on my ultimate limit state of my current elements. And okay, it's going to do a check value to check if the reinforcement is enough. And now if I choose refresh, then you will see at the bottom that it has commenced with the calculation of the automatic member design. And it will calculate the reinforcement, and it will also put it in there. Now there are 2 possible solutions: or it works fine, or it says that it's not possible. And if it's not possible, then well, you have to look where the problem could come from. So if you understand your elements correctly and you have dimensioned it at the correct size, then this option will work smoothly, and it will immediately give you the reinforcement design. So let's say we want to look at this part in detail. I'm going to take the rest of the structure back. And you can see that we have reinforced that bottom part. I'm going to send it, for example, live picture to engineering report. And now on my member, let's for example I'm going to use my member, my beam, and I'm going to use it for some checks. So I have the check for example, the crack control. So I'm going to use combination SLS. You can see that it's not possible to take the ultimate limit state combination. And let's do a crack control. And the crack control, it will indicate me that the cracks are not fine. Not completely. Well, let's do it only for the current element. It will indicate that my crack control gives a value of 1.28. Now, if I'm going to look more in detail to the crack, for example, itself, then it's going to indicate me that the crack which I have here, that's not the issue in fact. 0.279 and 0.3 is permitted. So in fact that is not a problem. So my moment is much bigger than my cracking moment, but there is no problem in the crack width. But if I look at, it will probably come from some different value. If I look at the amount of the minimal amount of reinforcement which is indicated through the crack control, then we also don't have a problem. And in Eurocode 2 you have these tables with distances, maximal distances between your longitudinal reinforcement dependent on the amount of stress which you have. And you can see that the problem arises from that distance. You also have a table with diameters, and that also gives me problems. So in fact, if I do the crack control, and if I would do the detailed calculation, then I wouldn't get any problems. My cracks are not too big. If I would use the method with the tables, then I would have a problem. But the method in the Eurocode to check crack control with tables is more conservative, and it already becomes clear in this check. Now I can also do a single check, which you can see here at the bottom, single check. And what does a single check do? Well, I have to select a member. Let's say I select the beam. And then I'm going to look in detail. I have to take force, let's say this one, do the calculation. And for the section indicated in red here, for that section I can look at these different tabs. For example, this is my cross section. You can see how this is reinforced. You can look at the loads applied on that section, the strains, the stresses, and then the 3D representation. And also for the different parts of that section, for example, if I take the reinforcement, you will see in the stress-strain diagram where that point is positioned. Here again, you're in your concrete stress-strain diagram, you are in the part which has tension, so you're not actually in the diagram anymore. And you can see that for different sections at once. And I can also look at the capacity check. I'm also going to do that for my current cross-section, let's say for my ultimate limit state combination. And what does the capacity control do? It looks at the maximal amount of forces that my reinforced section can take. It's going to compare that with the applied forces. So it will say we're at 85%. So the section is used for 85%. My reinforced cross section. And if I'm going to take a single check of this section, for example, then now it will be almost the same but a bit different. Now I can see for my current section, let's say in the middle, I can look at my interaction diagram. And my interaction diagram, it will indicate a diagram. And as long as my combination of forces is inside the diagram, then there's no problem. This diagram can be looked upon in two sections. You have the horizontal section and the vertical section. But as long as I remain in these two sections, then that means that I can take on these forces. And these loads, which you have here, are inside these horizontal and vertical sections. Otherwise, I would have an error. And I would have to solve that error by augmenting the amount of reinforcement or something else, but making the reinforced section stronger. That would be the solution. Now, that's for my 1D elements. I can do the same thing for my 2D elements. For my 2D elements, I can also ask for the amount of reinforcement which is necessary. So, for this part, I'm going to apply member data first. So, member data or individual settings, let's say for the top plate. If I want to input member data, those are settings which it uses to calculate. But you can also indicate the directions with it. And the directions, I've just clicked OK, but when you have concrete data on a plate, you will see the reinforcement directions. When I'm going to calculate internal forces or amounts of reinforcement, then those values which I'm asking is 1. Minus 1 means it's in the one direction at the bottom side. So it's the green one, which you can see here. The green one. And if I zoom out, then you will see that's the green one in the top plate. So if I'm gonna pick out the top plate, there you go, then it's in fact this plate, and the one direction is now the horizontal direction. If I choose member design ULS, I'm gonna take the ultimate limit state combination into account, and I should have enough reinforcement to take on these ultimate limit state forces. But if I take member design ULS and SLS together, then I'm gonna calculate reinforcement which is immediately sufficient to take both the ultimate limit state forces and the serviceability limit state forces, so that my reinforced plate can take on all those forces and also suffice to the crack control. And it's going to give here, you can see that there are quite some warnings. There were no errors, because those errors you would have seen in the message that appeared. So in fact, member design ULS plus SLS, the parts where I have warning 103, those I have to explain or look that it uses the minimal constructive superposing, so it uses the minimal reinforcement. How can I change the reinforcement rules that it uses? Well, if you are in a certain menu, let's say here, then you can go in the property to concrete setup, and the concrete setup that you will see then is a filtered version of all the settings for concrete, but those are the settings that are applied here. So you have, for example, your detailing rules, and all those things that are ticked on yes, they are used in calculating the reinforcement in this plate. For example, minimal transverse reinforcement or minimum tension reinforcement at the bottom side. We are using AR -1, -1. So the minus means that we are on the bottom side. So if I would tick this off, for example, and choose OK again, then I would have to recalculate my reinforcement. End result which I get then, it's not changed a lot, so there is also a different option, minimal reinforcement, which has importance. It has changed maybe a little bit, I'm not sure, but the warning is related to one of those options which I have just shown. Now to conclude, you will put all your settings into your calculation node. And that calculation node is something that gives all results in gives a summary of all results. Now the things that I will skip now, because I will go directly to the engineering report. Well, you can also calculate the deformation of cracked cross sections with Scia and additional creep deformation, or you could also do a punching check here, and you can also calculate pre-stress. Those things I'm not going to use here. I'm immediately going to go to my engineering report, which you can see here. Open engineering report and open it again. There you go. It's going to come here in the navigator. So let's activate the insert option. Now the things that I have sent are here in the inbox. Let's see, what do I have here? Displacement of nodes, document picture. Okay, those are the things I have sent through, so I'm going to regenerate now, all which was outdated. So I have two figures, displacements of nodes, and a table, which were sent to the engineering report. And they come here from Scia Engineer. Now, what else can I do? Let's say you have here this displacement of nodes. I can choose to export it as a 3D PDF later on. And now if I would want to add other elements, I could either send them from Scia Engineer to the report, or I can add them here. So if I tick on Insert, I can add, for example, let's say my set of load cases. Then I would have my different load cases. I can display them here. And for example, if let's say I wanted a figure that contains my loads. I'm going to activate everything, and I'm going to go to the load menu so that you can see a certain load case with different loads in it. Okay? Let's say we want this one. Okay, and I'm going to send it, well, maybe I should take the entire project, and I'm going to send it to, let's say, View, Live Picture to Engineering Report. Then in the Engineering Report, it has added this figure. There you go. And now it is possible to put this figure, which contains the loads indicated in load case 2, under my load case table. And then I will have that figure for each load case. So let's just put it under here, under load cases. And I'm going to regenerate everything which is outdated. You can see. And then it's going to say, well, for load case 1, well, the figure has a strange name, so I'm going to change it to loads. It should be clearer. There you go. For load case 1, your loads look like this. For load case 2, your loads look like this. For load case 3, your loads look like this. That's something you will receive. Or, for example, if I go to results, I can also choose to add internal forces, and I'm also going to put them underneath load cases so that I have my internal forces for each load case. You can see here it's almost done. Okay, and now for, let's see, where are we? Load case 1, my self-weight. You see description, self-weight. These are the minimal and maximal forces that I have for each type, for normal force, shear force, etc. And same thing goes for load case 2, load case 3. And like that, I can also add other things like headers and footers and page breaks, etc., table of contents. If it's done, then I can export it to, well, something like PDF, TXT, RTF, Word, or Excel, something else. You can also print it immediately. But let's export it to PDF. Then you will have this PDF. And this PDF, it will contain all the properties or all the content, let's say content, that you have inputted in your engineering report. And the figure which I have indicated as 3D PDF figure, that's something that you can look at in 3D in PDF. So that way people can look more in detail to something which you have sent. Now this property is just something that is in in Adobe, and something that we have also put into our engineering report. We did not create that in Adobe, they did. We just applied our program to it. So you can see that it's quite easy to put some things in the engineering report and then export it to something that you want to use. Now, to conclude, what I have explained to you is a bit about how you can model beams and columns and plates and walls and curved elements in Scia Engineer, different types of things, and then afterwards you just have to add some supports and check the model, the project. Also the loads. So the loads can be for a static calculation, but you can also apply dynamic load cases. And well, then the calculation will use all those loads and calculate your results. It's from a 3D structure, so it means that well, all forces will change if you change the 3D structure or you change some properties. So for example, changing thicknesses of plates can also change the forces in your model. And in the concrete design, I explained a bit about how you can quickly ask for reinforcement in beams and columns and plates and walls, and you can also do automatic reinforcement designs for beams and columns. And with the calculation report, which has dynamic figures, so these figures, they change if you change the project, and with it you can quickly put in multiple elements, and well, it's easy to export it to some other medium which you want to use. Mostly it's PDF, but you can also pick something else or print it directly. So I would like to thank you for your attention. Now, if there would still be questions at the end, then you can then you can contact us. So if you have some technical questions, you can contact us at support. That's support@sciaonline.com. Or if you would have some commercial questions, then you can contact our sales. So furthermore, I thank you for your attention, and I hope you have a nice day.